Alright, in this video I'm going to do a proof, an algebraic proof, and I'm going to use this example here. We've got 1 minus cosine of x over sine of x plus sine of x over 1 minus cosine of x, and all of that equals, apparently, 2 times cosecant of x. What I've been telling my students to do is try to work with the complicated side of the equal sign or the equation and simplify it until you get the other side. So it looks like this one is probably the more complicated side. So I'm going to start with this. Now, whenever I do these proofs, I always say as well, there's more than one path to simplify it, but right now I'm seeing fractions and I'm saying I can't add them because I don't have the same denominator. So I'm going to multiply this fraction by this denominator over this denominator so that I can get a common denominator. Wow, that's a lot of denominators. Okay, so this is what it looks like. 1 over 1 minus cosine of x divided by 1 minus cosine of x. That is equivalent to 1, and I'm going to multiply that times this piece. And so I'm always looking for that. Anytime I see fractions I need to add or subtract them, I'm always looking for the same denominator. And the easiest way to do that is to multiply times the other fraction's denominator over itself. So this will be sine x over sine x. And that came from here, right? Because what I want, if I just keep coming down, right? If I keep coming down, if I multiply the numerators, I'm going to have 1 minus cosine of x. That's going to be squared. And the denominator is going to be 1 minus cosine of x times sine of x. Over here, I'll get the same denominator, right? I'll get 1 minus cosine of x times sine of x. Now, I actually just wrote the denominators differently. I don't know if you caught that, but I didn't put parentheses here, but I did here. It doesn't matter for that part, but the parentheses on this part really matter. And so I was helping students, and I noticed someone didn't put parentheses around this. If you didn't do that, that would mean a different thing. So I'm multiplying this whole denominator here by this whole thing. We multiply straight across. And the same thing happens here. I have 1 minus cosine x times itself. That's why I could put all that in parentheses and that's squared. Here I've got sine of x times sine of x. That's going to be sine squared of x. All right? So now I can see that I have the same denominator. If I add those two together, I get 1 minus cosine of x squared plus sine of x, sine squared of x divided by 1 minus cosine of x times sine of x. Alright, so again, anytime I see fractions in the beginning, I'm just like, alright, well, how am I going to add them? I need the same denominator, and this step comes up again and again and again. Now I'm here, I've got the same denominator, I add them, my numerators are now added, and I have that denominator. I'm going to move to the right a little bit. Alright, so 1 minus cosine of x, that whole thing's squared. That should remind you of this algebra piece. I'll just write a small note over here. Imagine if we had, let's see, what if we had 1 minus x and that was squared? Your instinct might be to write 1 minus x squared, but that is not the case. 1 minus x times 1 minus x is 1 times 1 is 1. This is negative x, and this is negative x. So the top becomes positive x squared. And when I pull all that stuff out of the box, I get 1 minus 2x, because there's two negative x's that combine, and then plus x squared. Okay, something similar is going to happen right here with this one. 1 minus cosine of x, and that whole thing squared is 1 minus 2 cosine of x plus cosine squared of x. And then I'm going to continue to write my numerator, plus sine squared of x. And that move right there was really important. It's really important because I need, in the end, when I finish simplifying all this, I'm not quite done, I need a 2. I can see a 2 already. Now, it'd be nice if everything else canceled and I had a cosecant. So that's what I'm going to try to do next. I'm going to keep coming along. So this equals, and it's going to come on down here, right? Come on down, let's see. I'm going to try to combine some stuff here. Can I combine anything? Well, there's no like terms. There's no plain numbers. There's no cosine x's to combine. However, let's see. There is a sine squared and a bunch of cosines. So maybe I'll change this sine squared. And so if you go to, hopefully you have a formula sheet, sine squared's on there. This can actually be rewritten from the Pythagorean identity as 1 minus cosine squared. So I'm going to rewrite the numerator. It's 1 minus 2 cosine of x plus cosine squared x. And then I'm going to rewrite this whole thing. So this is plus 1 minus cosine squared of x. That was sine squared. Okay, that's all that I changed. And again, that's a Pythagorean identity. It's a different form of the sine squared plus cosine squared equals 1. If you mess with that one a little bit, you'll get this one. All right, so you got to be able to recognize that. Okay, so let's see. We're moving along. It kind of looks more complicated, but what I'm trying to do, I'm going to end up getting rid of this negative cosine. I'm going to write it a little clearer for a second here. So this is going to be 1 minus 2 times cosine of x plus cosine squared of x plus the 1, and then minus a cosine squared of x. All right? All of that is still over the same denominator. Great. So, looking at my numerator now, I've got a cosine squared x, and it's positive, and I've got a negative 1. So those are going to cancel. All right? So then I've got a 1 minus 2 cosine x and a positive 1. So there's a 1 and a 1 that can combine, and I'm going to come down here and do that. That can combine to give you 2. Just plain old 2. 2 minus 2 cosine x. That's all that's left up top. Right? Everything else was gone. This 1 combined with this to make that 2. Okay? And now I've got 1 minus cosine of x times sine of x on the bottom. And now I'm looking at the numerator and I'm saying, oh, there's all these 2's there. Let me factor 1 out. So the numerator is really 2 times 1 minus cosine of x, which is really awesome because I have a factor in the denominator that is the exact same. So this is 2 times this, and this is that thing times sine. So those factors, 1 minus cosine of x, cancel out. It's just 2 things multiplied, right? The factors cancel. So I'm left with 2 over sine of x, which equals, I'm going to come all the way down here, that equals, if I have a sine of x on the denominator, that's really the same as 2 times cosecant of x, which is exactly what I wanted. And so I am done because I simplified the left side, and I'm simplified and simplified and simplified, and I got the right side, 2 times cosecant of x. That's what I originally wanted in the problem there. So again, when you're doing these, a lot of different paths. If you see fractions though, you probably want to be able to add them, so you need the common denominators. And then from there, you're just applying the identities that you may or may not have. One key piece here, in the way that I wrote all this, look at those spaces I left between each one, right? So do that. Make sure your equal signs are lined up and everything you're writing is mathematically correct, right? Just organize your work. I use almost more than a half a sheet of paper here in this one problem. So there's no sense in like trying to squish it all in a small section of your paper. So use the space that's there. Good luck.